Forget the asteroids. Forget the supervolcanoes. Forget nuclear war, alien invasions, or rogue.
Black holes swallowing us whole. Those are all quick deaths. Dramatic, cinematic, the kind of thing that makes for good disaster movies. But that's not how Earth is actually going to die. The real death of Earth is going to be slow, inevitable, and so far in this
future that it almost doesn't seem real. We're talking billions of years from now.
But here's the thing, it's already been set in motion. The clock is ticking. And there's absolutely X4 nothing we can do to stop it. Today, I'm going to walk you through the actual, scientific, unavoidable death of our planet. Not some hypothetical disaster. Not a what-if scenario. This is what will happen. This is the guaranteed end of Earth. And honestly, it's what's both terrifying and beautiful in the most cosmic way possible. Welcome to the heat death of this Earth. Population 0. Let's start with the villain of our story, the sun, that big, bright, life-giving ball of nuclear fusion in the sky that makes everything on Earth possible. Yeah, that thing. It's gonna kill us. Eventually. And it's gonna take its sweet time. Doing it. Right now, the sun is a pretty stable, middle-aged star. It's been burning for about 4.6 billion years, and it's got another 5 billion years or so of fuel left. But stars don't just burn their fuel and then peacefully fade away. Oh no, they go through stages. And some of those stages are really, really bad for any planets that happen. Here's what's happening inside the sun right now. Deep in its core, hydrogen's atoms are being fused into helium through nuclear fusion. This process releases an pistic amount of energy, which creates an outward pressure that balances against the sun's gravity.
Trying to collapse it. It's a perfect equilibrium. A cosmic tug-of-war that's been going on for
billions of years. But here's the problem. Every second, the sun converts about 600 million tons of hydrogen into helium. That helium ash builds up in the core, and helium doesn't pour as easily as hydrogen. So the core gets denser, hotter. The sun has to work harder to maintain that equilibrium. And as a result, the sun is slowly getting brighter. About 10% brighter every billion years. Doesn't sound like much, right? Except that extra heat happens. Big ones. Fast forward 1 billion years from now. Earth is already in trouble. The sun is now about 10% brighter than it is today. That extra solar radiation is heating up the planet. Global temperatures have risen by several degrees. The ice caps? Long gone. Melted completely. Sea levels have risen hundreds of feet. Coastal cities, the ones that abandoned centuries ago, are now underwater ruins. But it's not just the heat. The increased solar radiation is doing something worse. It's breaking apart water molecules in the atmosphere. Ultraviolet light hits H2O, splits it into hydrogen and oxygen. The hydrogen, being super light, escapes into space. The oxygen either gets locked into rocks through oxidation or also escapes. Earth is losing its water. Slowly but surely, the oceans are evaporating into space. And there's no way to get that water back. The remaining oceans are shallow, warm, and increasingly salty. Marine life is dying off. Coral reefs are extinct. Most fish species are gone. The food chain has collapsed. Any humans still around, and that's a big if, are living in underground habitats or near the poles where it's slightly cooler. But even the poles aren't safe for long. 2 billion years from now, Earth is a desert. The oceans are gone, completely evaporated. The surface is a barren, rocky wasteland. Temperature the day reach 140 degrees Fahrenheit or 60 degrees Celsius. At night, with no atmosphere to retain heat, temperatures plummet. Wait, no atmosphere? Yeah, that's gone too. without liquid back into the atmosphere. Without CO2, there's no greenhouse effect. Without a greenhouse effect, the planet can't regulate its temperature. The atmosphere just dissipated. Any remaining life, if there is any, exists only in the most extreme refuges. Deep underground, maybe, where pockets of liquid water might still exist. But surface life? Life on Earth is over. And the sun is still getting brighter. 5 billion years from this verse. Now, this is where things get really interesting. The sun has burned through most of the hydrogen in its core. The core is now almost entirely helium. And helium, remember, doesn't fuse easily. So the core starts to collapse under its own gravity. As it collapses, heats up. A lot. The temperature in the core skyrockets. And this triggers a new phase of fusion in a shell around the core. Hydrogen that wasn't in the core starts fusing. And this shell fusion is actually more energetic than the core fusion was. The sun begins. This is the red giant phase. And it's absolutely catastrophic for the inner planets. Over the next few 100 million years, the sun swells up. It gets bigger and bigger. Its surface cools down, which is why it turns red, but its total energy, the output, increases dramatically. Mercury, the closest planet, gets swallowed first. The expanding sun just engulfs it. One day Mercury is a planet. The next day it's just atoms, being vaporized in the outer layers of a dying star. Venus is next. Same fate. Swallowed. And then it's Earth's turn. Now, here's where it gets a bit uncertain. Scientists aren't 100% sure if the sun will actually engulf Earth or just come really, really close. See, as the sun expands, it loses mass. Solar wind carries away the outer layers. And as the sun loses mass, its gravitational pull on the planets weakens slightly. Which means Earth's orbit might drift outward just enough to avoid being consumed. Might. But even if Earth escaped swallowed, it doesn't escape being destroyed. The sun, now a red giant, is so close.
About this. Okay, back to the death of Earth. We're now about 7 to 8 billion years in the future. The sun is in its final stage. It's shed most of it, and outer layers, creating a beautiful planetary nebula, a glowing cloud of gas expanding into space. All that's left of the sun is its core, a white dwarf. A star corpse about this dwarf is incredibly hot, over 100,000 degrees Celsius on its surface, but it's no longer producing energy through fusion. It's just slowly cooling down over trillions of years. And what about Earth? If it survived the red giant phase, it's now a scorched, airless rock and orbiting a dead star. The surface is barren. No water, no atmosphere, no life. Just a cold, dead ball of rock and metal drifting through the darkness. But the story doesn't end. Because even rocks don't last forever. Over the next several billion years, Earth and orbit will slowly decay. Not because of the sun's gravity, but because of gravitational caudal interactions with other planets, asteroids, and the general chaos of orbital mechanics. Orbit aren't perfectly stable over these timescales. They're chaotic. There are a few possible fates for Earth at this point. Option 1, Earth gets ejected from the solar system. Gravitational perturbations from Jupiter or another massive object could sling Earth out into interstellar. Earth becomes a rogue planet, wandering the galaxy alone in the darkness. Forever.
Option 2. Earth collides with another planet. Maybe Venus. Orbital chaos could lead to a catastrophic collision that shatters both planets into fee. Option 3. Earth spirals into the white dwarf. Over billions of years, it slowly loses orbital energy and finally crashes into the remnant of the sun. Earth is vaporized, torn apart by tidal forces and consumed by the white dwarf. Any of these options is possible. And honestly, it doesn't really matter which one happens, because by this point, Earth I would call already dead. It's been dead for billions of years. This is just the final cleanup of the sporps. But let's talk about something even more depressing: the universe itself. Even if Earth somehow survived all of this, even if it avoided the sun's red giant phase, avoided orbital decay, avoided collisions, it still wouldn't last forever. Because the universe I join too. We live in an expanding universe. Galaxies are moving away from each other, and that expansion is accelerating. Eventually, billions of years from now, the expansion will have. The sky will go dark. One by one, the stars will disappear from view. And then, some will explode as supernovae. Others will fade into white dwarfs, then black dwarfs. But states. Eventually, there will be no more stars. The remnants of dead stars and planets. This is called the heat death of the universe. Maximum entropy. Everything is spread out evenly. No more energy gradients. No more chemical reactions. No more life. Just an endless, frozen darkness that lasts forever. And in that crystals, the darkness, whatever's left of Earth, if anything, when the universe was young and full of light and life. Pretty bleak, right? But here's the thing. This is all so far in the future that it's almost incomprehensible. We're talking about timescales longer than the entire history of complex life on Earth. Longer than the age of the Earth itself. These are numbers so big they lose all meaning. Humans won't be freaks around to see any of this. We'll either be extinct, or we'll have evolved into something completely different. Or, if we're really lucky and really smart, we'll have left Earth with one step ahead of cosmic disasters. But Earth? Earth is stuck here. It can't run away entirely and spread out across the galaxy, hopping from planet to planet, star to star, staying one step ahead of cosmic disasters. But Earth? Earth is stuck here. It can't run away. Forts from the sun. It can't avoid its fate. The planet that gave birth to life, the full planet that nurtured us for millions of years, will eventually be consumed by the very star
that made it possible in the first place. There's a certain poetry to it, don't you think? The sun gives life, and the sun takes it away. But before you spiral into an existential crisis, let me put this in perspective. We have billions of years. Literally, an existential crisis, let me put this in perspective. We have billions of years. Literally.
But our death? That's optional. We have the potential to outlive our planet, to weave the legacy of Earth with us wherever we go. Every tree, every animal, every ecosystem, we can preserve it, study it, recreate it on other worlds. Earth may die, but the braille life it created doesn't have to. And maybe, just maybe, billions of years from now, some distant descendant of humanity will look back at Earth, at this tiny, dead rock orbiting a fat, white dwarf. And they'll remember. They'll remember where we came from. They'll remember the world that started it all. Earth will be dead, but it won't be forgotten. That's the
real story here. Not the death of the planet, but the survival of what the planet created. Life.
Die. Earth will die. Even the universe will die. It doesn't have to end with the planet. It can keep going. As long as we choose to
keep it going. So yeah, this is how Earth actually dies. Slowly, inevitably, consumed by prone star after billions of years of loyal service. It's not dramatic. It's not sudden, but it's real. And it's coming. But we still have time. So much time. Time to explore. Time to grow. Time to make sure that when Earth finally takes its last breath, we're not there to die with it. We'll be out there, among the stars, carrying the memory of home with us. Forever. But that's a story for another What If.